Hey, this is Kellen.
And this is Marissa.
And we did our project on the conservation of energy.
And how it affects people when they're jumping on the ground and off the diving board. This is Michael, and he's our example for this experiment because he weighs about 150 pounds. The law of conservation of energy states that initial energy equals final energy,
where potential energy equals mass times gravity times height, and kinetic energy equals half mv squared.
The first experiment is a person jumping on the ground.
Because there is no give in the ground, there isn't any potential energy. And there isn't any final kinetic energy because at the top of the jump, there is only potential energy.
Therefore, the kinetic energy initial equals the potential energy final. Because mass is on both sides, you cross it out. Then you find velocity. Velocity equals distance over time. For distance, we use the crouch height times 2 because it is the distance you move before you leave the ground. Gravity is 9.8 meters per second, and the given crouch height is 0.4 meters, and the time is 2.25 seconds. Thus, the velocity is 3.2 meters per second.
Then we're going to find the height, so we rewrote the equation and divided both sides by g to get v squared over 2g, and then we plugged in all the numbers and got 0.52 meters.
This time we'll be using the law of conservation of energy to find the height of a jump on the diving board. The kinetic energy final again will equal 0 because of the same reason as it did before, and that there's only potential energy at the top of a jump. Potential energy initial, however, will equal something a little different. It will equal 1/2 the spring constant times distance squared, which is a lot like the kinetic energy equation, because the diving board uses the spring constant, so you will need to multiply that times the displacement of the diving board pushing down.
So we have the displacement, which is x, which is 0.8, and the mass, which is 68 kilograms, and the acceleration of gravity, which is the usual constant, 9.8 meters per second.
To find the spring constant, we will need to use Hooke's law, which is F equals K times displacement.
So we're going to rearrange that to get K equals F over X, and then we're going to use mass times acceleration for F to get K equals ma over x, and then we're going to plug in all of our numbers to get 833 newtons per meter.
After you find the spring constant, you plug into the law of conservation of energy to find the height. Height equals 1/2 times the spring constant times the displacement of the diving board squared, plus 1/2 times mass times velocity squared, divided by mass times gravity. Then you plug in the numbers as shown on the piece of paper, and you get the height to be 0.92 meters. And then you realize that you're twice as high as you would be on the ground. Yay, diving boards!
Which tells me you're not getting your head up